All right, guys, here we are on solving special systems. So in this section, we are going to talk about some special answers. We've talked about these before, so some of this should seem very familiar. So you can see here, we're going to talk about one solution, no solution, and infinitely many solutions. And we'll come back to this verbiage here, but it is important as we work down through this. So, example one says solving a system. It's going to have, it says right here, no solution, but we're going to solve by graphing and by substitution. So if you remember when you graph, we're going to start with this equation. You hit that y-axis, put the intercept on, then use rise over run. So 3 is our slope. We can make that 3 over 1, excuse me. So I can rise 3 from here. 1, 2, 3, run 1. I hit the y-axis. I put the intercept on. Rise 3, run 1. Rise 1, 2, 3, run 1. You could keep extending that pattern down this way. I feel like the more points you put on, the easier it is to try to make a straight line. Of course, you should use a straight edge. So there's that one. And then to graph this second equation, here it is, hit that y-axis, -3, put the intercept on, then use rise over run again. So 1, 2, 3, rise, run 1. 1, 2, 3, rise, run 1. 1, 2, 3, rise, run 1. And connect. Okay, so it says solve. So we have graphed it, but now we have to figure out what that answer means. So if you look back up here, here in the middle where it says when the lines are parallel, there is no solution. Throughout this chapter, we have been graphing lines that cross or intersect. So when they do not intersect, you say there is no solution. I'm just going to write no solve. We can also work this equation by substitution. So I'm going to show how it works that way. So I'm going to take this one, substitute it in down here. So now over here, I've got 3x plus 1. Bring my equal sign down, 3x minus 3. When you're solving an equation and there are variables on both sides, we can take off as many variables as we can from each side. In this case, we can take 3x from there and there. We're left with 1 equals -3. And you should be like, what? No, it doesn't. Nope, it does not. So when we get an answer that does not, when the variables are eliminated and what's left does not work, is not equal, that's false, you say no solution. So we just worked that problem 2 different ways, by graphing and by substituting, and both we got no solution. Let's keep it going. On this next one, again, we are solving by graphing and substituting. So this top one's ready to go, y equals mx plus b format. Hit the y-axis, put the intercept on, then use rise over run. 1, 2, 3, up, run 1. Rise 1, 2, 3, run 1. This is actually the same line as we had up above. I'm going to extend the pattern down here to make it kind of easier. Oh, I'm still terrible at lines on here. You use a straight edge. So there's that top one. Problem with this one, it is not quite ready to graph. The equation does not say what does y equal negative or y minus 3x. It needs to be y equals mx plus b. So this needs to get over to the other side. How do you get rid of minus 3x? You would add 3x. It's going to cancel over there. And then on this side, we also have 3x plus 1. So if we went to graph this, it's going to be the exact same line. So same line. If we go back up to what we have at the top, I only see one line here, so the lines are the same. That is going to be infinitely many solutions. If we're looking for where they intersect or cross or touch, they are touching each other everywhere. They're the exact same line. So same line would mean infinitely many solutions. I'm going to abbreviate that with IMS. It also said to solve it using substitution. So I'm going to take, let's see what I'm going to do. Since this is already solved for y, I'm going to take this and I'm going to sub it down into this other equation right there for y. So y equals this. So now I'm going to rewrite this over here. You can notice my change in color. Instead of y, I'm going to write 3x plus 1. And then I go ahead with the rest of the equation. I write minus 3x and then equals 1. Combining like terms, you've got a 3x here and a negative 3x. Those are gone. Goodbye, canceled. What I have left is 1 on this side and 1 on this side. When your variables are eliminated and you have a true statement that's left, that's when it is infinitely many. And again, normally I just let you abbreviate that as IMS, but make sure and do what your teacher suggests on abbreviations. So that's how you kind of look at both of those in graphing and substituting. Down here it says, is it possible to know how many solutions you will have without graphing if the equations are in slope-intercept form? The answer to that is yes. Hooray. You don't always have to do a ton of work. So this is where you're going to look all the way back up to the top of the page, and you can use that information right there to answer that question without solving. So go ahead and flip it over. Next page. Pay attention to what your teacher says as far as these. Either do them on your own or wait for class tomorrow, depending on your teacher. So we've got, looks like 6 on your own problems. The ones up here, we're going to actually solve. The ones down here, we're going to do without graphing or solving. So we're just going to use that information. Last one, let's go through this example 3 together. It says the perimeter of the rectangle is 36 units. So I'm just going to write P for perimeter equals 36. The perimeter of the triangle is 108 units. I'm going to go ahead and write that one on here. You should do the same. Write a system of linear equations to find the values of x and y. So it doesn't actually say to find them. It just says we're going to write that system. So we just need to write an equation for both the rectangle and the triangle. So perimeter is the, you add all sides. It's the distance all around. So add all sides. So common mistake here is to just put these two down. However, this rectangle clearly has 4 sides. So we've got a 2x on the bottom and a 2x on top. I'm going to go ahead and write those together. I did 2x plus 2x. That's how I got that. I've got a 4y on the left, a 4y on the right. Together, that makes 8y. And again, that was my 4y on the left and my 4y on the right. Those all add up to 36. So there's one equation for the rectangle. I'm going to do the same down here. I'm going to go ahead and combine my like terms. 6x on the left, the 6x on the right make 12x, plus the 24y on the bottom. And that covers all 3 sides of that triangle, and that is equal to 108. So we have written a system of equations. A system is just 2 or more equations. We've got that. We are good. Good work.